So on our first time around, we did everything with arithmetic sequences and made sure we know what the difference was, which adds or subtracts to find the next sequence or next term in the sequence. So we're doing something very similar, just with geometric sequences, which instead of adding, subtracting, multiply or divide, right? So in all these, you're going to know for sure it's a geometric sequence, but also think about how would you tell if it's not told to you whether it's arithmetic or geometric, because you want to be able to tell the difference without it actually being explicitly said. But on here, we can always find a common ratio if there is one, right, by multiplying or dividing the second term divided by the first term. Right? So 32 over 64 is exactly 1/2, which we really need here because we can't tell by looking at these points what they exactly are because of the scale counting by tens. So we really need that. So we can just take half of each of these. So half of 32 is 16, right? Half of 16 is, and then half of 8 is, right? And half of that is, and half of that, right? So we can come up with all our missing terms just by knowing the common ratio. And we can also write an explicit rule, which is going to be of this format, very similar to the arithmetic. We have our starting point. We always, if we have the first term, we always want to use that. So in this case, it's 64. We have our ratio, which is 1/2. We know that. And much like the arithmetic, we also do n minus 1. And the 1 here, minus 1, corresponds to that term that we're using that goes with 64. So if I use minus 1 here, I have to use 64. If I didn't have that, I could really use any term, and it'll still give me the same terms if I plug them in. Okay, the step we're going to take a little further today is, like yesterday, we want to write this in a more conventional way, which is function notation that has this format. F of n to the a, b to the n power. So we don't have that n minus 1, which really what we're doing is we need the 0 term. Right? Even though a 0 term doesn't exist in sequences, we can work backwards to find it, as if it did. So if I take this and I want to find, let's say here, I'm going to move it over here, the 0 term, I could just work the ratio backwards, right? And from right to left instead of left to right, and I could just times 2 to get 32, times 2 to get 64. So my 0 term would be 128, 64 times 2. So my full function notation would be f of n, 128, same ratio of course, raised to the n minus 0 or just n power. So just know that these two are equivalent. They give you the same values. But for problem solving purposes, it's much easier when we have this format and we have a y-intercept as opposed to just starting on 1. And we'll find out that a little later when we start doing some of the problems. So that's basically it. We're going to start off with finding the ratio and write the sequence notation and then write a function notation. Nothing more than that. Okay. So scroll down here. So same idea, except this time we don't have consecutive values. So we can't find the ratio unless we have consecutive values. So what we need to do first is find out what this a sub 2 actually equals. And we know it's a geometric sequence. So we have a method for finding a missing term that's in the middle. So usually if this is arithmetic and you want to find the middle term, it's also called a midpoint. You would add these up and divide by 2, but with a geometric, it has its own geometric mean, which instead of adding them up, you multiply them. So 144 times 36. And instead of taking half of it or dividing by 2, you take the second root, also known as the square root. So that will give us the middle term of a geometric sequence when one number is missing. So root 144 is just 12. And root 36 is just 6. So we have 12 times 6, which is 72. And with that, we can now find a ratio, if you need to, 72 over 144, which just comes out to be 1/2 again. So same ratio as last one, just with a different starting number. So we got half of 144 is 72, half of 72 is 36. What is half of 36? And what is half of that? And half of 9 is just 9 over 2. And what is half of 9 over 2? 9 over 4. And it's a good idea to leave these as fractions. Do not make them decimals. Leave them as fractions. Just because it's easier to get the answers if we just multiply the bottom by 2 instead of trying to do everything with decimals. Now, if this is a word problem, and depending on the word problem, we might want to make these decimals because that's what makes sense in the context of the problem. But without a word problem, we can just leave it as such. All right. And once again, just like yesterday, it does ask, what is the domain? And what is the range? So it just lists those out formally. And the purpose here is just to reiterate that these are not connected. We don't have any fractions or decimals in between these numbers. It's only these numbers, 1, 2, 3, 4, 5, 6, and 7, and nothing else. So that's why they appear as coordinates on a graph, something like this. They're just dots and nothing is connected because there really is no value. Remember, this stands for the first term, second term, third term. There's no such thing as the 1.5 term or the 2.75 term. And the range is just the corresponding a sub n values, and we'll keep them in the same order. There we go. Now go ahead and try to do number 10, which is the same as what we just did up here. Write the sequence rule and also the function rule, but using this information instead. So what is the a sub n rule? And also, what is the function rule? And if we reverse this up here, once again, instead of taking half, take a whole, multiply by 2, top and bottom. N minus 0, or just n. And there you go. And so hopefully we see a pattern between these two. All right, and we can naturally move back and forth. If we had to, we could also use any number in the middle as well. So all numbers will work, but as a standard form, we like to have it a certain way. All right, flip it on over. You'll see something familiar compared to yesterday, although everything is in geometric terms. And yesterday we had to find 2 points that were on these lattice points just to make sure we're getting an accurate difference. However, you see here we don't have that at all, so that the terms are actually given to you already above. So you just have to record those down. Because without this being given to you, there's no way to accurately estimate what these are. So, and from here we can hopefully see what that ratio is. How are these going up from each other? And the right 2 columns are the same as yesterday. Just fill them in with a sub and the f of whatever term number you're on. Six and a sub n. There we go. And just like on the last problems, you can write both the subscript and the function version using the first term for the subscript and finding the 0 term for the function. This one's going to be 2. 2 to the n plus 1. All right, what will be this a term here for the function? Yeah, so if I reverse this, and you can see I'm dividing by 2, dividing by 2, dividing by 2. So 3 divided by 2 is 3 over 2. 3 over 2. Okay, hopefully so far so good. And when you're ready, go ahead and try 12. This is just a repeat of what we've kind of already done so far. We should be able to do this begin and end on our own now. You can see the ratio is 1/2 once again. So half of 6 is, and then carry on till the 6th term. And leave these as fractions. It's much easier, right? No calculator needed. Just multiplying the denominator by 2 each time. So if we start throwing in calculators and start getting a bunch of decimals, you lose sight of the pattern. If we have like 1.5, then 0.75, and then 0.375, the pattern kind of gets lost when you move and use decimals. So we like to just keep it this way, unless of course there's a word problem. Then we would probably change it to decimals. Okay. Find the a sub 0 term, so just like the others. Right, this is the first, this is the second, and so on. So if I want to find the 0, just do the ratio backwards. So instead of dividing by 2 or multiplying by 1/2, I'm going to multiply by 2. So 3 over 2 times 2 is just 3. 3 times 2 is 6. And then 6 times 2 is 12. And you can just write that just by saying a sub 0 is going to be 2 times 12. You might see some places written like this, where you just use the inverse, 1/2 inverse. Sorry, times 6. So if you're moving from left to right, you're multiplying by 1/2 each time. If you're multiplying right to left, that's why it's inverses, because we're going the other direction, which is the same as 2. 1 over 2 to the 1/2 to the negative 1 is equal to just positive 2. So either way, it gives you 12. Okay. And now use that as our function a value, 12. And we have a ratio of 1/2 and to the n power. All right, so pretty, hopefully straightforward. A lot of familiarity with everything we've done before this. All right, we'll flip it on over for our last page of just a few word problems. All right, so this is saying Tim released a helium-filled balloon that rose 200 feet in the first minute. In each succeeding minute, the balloon rises only 50% as far as it rose in the previous minute. Right? That's because the air is getting thinner, and as the air gets thinner, it's harder to move an object up. Right? Write a general formula, A sub n, that gives you the number of feet risen during the 9th minute of the balloon. Okay, so we know where we're starting, right? So we have the first term. That's nice. We know the ratio, right? It says 50%. What do you think that is as a ratio? Hey, our friend 1/2. So we got 1/2, just keeping it light, to the n minus 1. So we can use this to find where we are going. Let's see here. So for the second minute, what would it be? If our ratio is 1/2, what are we doing? 100. Yeah. And then 50. Then. All right. And then 12.5. Good. And then half of 12 is? Half of 0.5 is? 6.5. All right. So you might be tempted to pick up your calculator for some of these, but do them until it's needed. Right. So half of 6.25, 3.125, and half of that is 5, 6. What was it? 2. Okay. There we go. So here we go. There's the height of the balloon. It reaches after 8 minutes. Okay, so what is the height of the balloon after 8 minutes, according to this? So after 8 minutes of going only up, is this the height of the balloon right here? Now, hopefully we can look at that and say, common sense, no, it's been going up nonstop. How could it be going up nonstop and then we're only 1.5 feet off the ground? So we got to read this carefully because our data is not wrong, but how to interpret it might need a little work. So this is saying, if you look back at it very carefully, each succeeding minute, the balloon only rises 50% as far as it rose in the previous minute. This is telling us what our y values or our a sub n values actually mean. So what it doesn't say is this is the total height at that time. It's not saying that. It's just saying from between the first minute and the third minute, it rose another 100. And between the second minute and the fourth minute, it rose another 50. So this isn't cumulative. This is just saying how much it rose for that 1 minute only. So if you want to look at the total at 2 minutes, you would have to add all the previous. So you'd have to add those two together. And that's the total. And if I want to know after 3 minutes, I'd have to add that much. Then I would have to add another 25. Then I'd have 384.5. And I'd have to keep adding these over and over and over. 390.75. And just keep on adding these nonstop, which you can do, which is fine. But you remember we probably did this already. We did a little shortcut. If we need to add up all these together, you can use the sigma notation. So that's why I had you guys get your calculators. So once again, we can practice this. Where we're going to add up all the n values from 1 all the way to 8. All 8 of those of this sequence. And we can just put it in the calculator and press those buttons and then get the total that way as well. So recall, grab your calculator, find the summation. All right, that's under math. And you go down, 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 down to 0. So once you know it's at 0, you can always just press math and then 0, and that will pop it up. Or you can scroll down every time, but it's a little faster if you learn those menus. And now we just put in the values. You're going to use x instead of n. So put in the from x equals 1 to 8. And then our sequence, 200, parentheses, I'm going to use 0.5, just a little bit easier than a half, and to the x minus 1. All right, should look like that. And hit enter. And voila, it says 398.44. I have mine rounding to 2 decimal places. And you get the same answer if you just kept on adding the last two together as well. It would come out the same. So if you don't remember that, it's okay. You would just have to manually do all those. Type them all in. But hopefully that helps a little bit. And you realize the most important thing about this problem was not the numbers. It was interpreting what your numbers actually meant, which the higher you get in math is actually more of the problem of getting some information and looking at it and say, wait a minute, that's doesn't make sense. What, how should I re-understand this so it does make sense, right? That's the more the critical thinking part that you have to work on than anything else, okay? And let's also put some units on here since it is a word problem. These are how many feet it is in the sky. Which is pretty high up. Okay. All right, lastly, there's one more. So we have lastly, a big tech electronics advertises a monthly payment plan for the purchases of best-selling tablet. All right, buyers pay $50 at the end of the first month, $55 at the end of the second month, $6.50 at the end of the third month, and it keeps on going and going and going. So write that out, jot that down. So first month, it's 50, then it's 55, and it's 60, 50. And then they ask, what is the 4th, 6th, and 10th? So we get 1, 2, 3, that's the 4th. We'll have the 5th will be something, and then we'll need the 6th. And we'll have the 7th, the 8th, the 9th, and then we'll also need the 10th. All right, so very similar to everything else. What do we do first on every other problem? What do we find? Yeah, do that again. What is the ratio, right? Nothing's changed. We still need that to really go anywhere on these problems. So this time it's not obvious. So since it's not 2 or a half, you probably have to use what we did earlier, like on this problem. We just had to divide the second by the first to get the ratio, right? You just have to use that when it's not just obvious what they're multiplying or dividing by. So we can do that here. So we got 55 over 50, which equals 1.1. And then you could test it, do 1.1 times 55, and you'll see you get 60.5. So we can do that again. Multiply by 1.1. That gives us the 4th, which is 66.55, and so on. And then we got to find the 5th, just to get to the 6th, and then the 7th, 8th, 9th. And it seems like a lot of work just to do that. So while we have our calculators out, I remind you, if you need a table of values, you can use the table on here, right? You can go to here and type in our function, which we know is going to be 50, 1.1 to the x minus 1 on your y equals, like so. So punch that in. And then go to second and table. You don't need to graph it, but just go to second table And you'll notice it gives you all the values. 1, 2, 3, there's 4, 60.55. I already set this ahead of time to round to 2 decimal places since we're dealing with money. So in the mode, I've already done that. So it's already rounded, and I can find a little bit easier. I can find, okay, the 6th is 80.53, and the 10th, 10th, I was trying to find, yep, 117.9. So nice way to use your calculator, not for graphing, but for just for finishing this table, so we don't have to calculate as much. So we got 80.53, and the last one was 117.90. All right. Now, how much will the customer pay for this entire for the tablet with this payment plan? So we have to add up once again all these numbers. So much like the last time, it's probably a good idea to use the summation and just have it added up for you. Okay. And how many payments were there total on this? Is it 10 or 12? 12, yes, because it does say here for 1 year. Even though this question said just find the 10th month, it doesn't imply that that's the last month. Right? So careful, we have to input the right numbers. The calculator is only as smart as us. So first month through the 12th month of our function. And then we're going to round that to the nearest cent, whatever it might be. And that actually answers C as well. We already have our function. Okay, so we can punch this in. We have 50. 1. There we go. And it comes out to $1,069.21. There we go. And we can work backwards, find our zero term. So if we're going the other way, we'd have to do 50, and we can't just do it obviously, but remember we're multiplying one direction. That means if we're going backwards, we would divide by 1.1. So our next function here will be 50 divided by 1.1, and then we'll have 1.1 raised to n minus 0, or just n. And then in the calculator, find out what 50 divided by 1.1 is. We get 45.45. All right, there we go. And lastly, what does the ratio represent in context of the scenario? So what is 1.1? What does that actually reference? Why is it 1.1, not 1. Just 0.1? And think about the problem. Would you ever do this? Would you say, okay, it's $50 for the first month, but then the next month you have to give me 55, and after that you have to give me $60.50, and then on that 6 months and that 10th month you have to give me $117? Would you ever buy something like that? That makes any sense? Unfortunately, that's what most people do, because this is a credit card. This one means you're paying for the original price of the tablet, and this 0.1 is a 10% interest on it. So if you just make a minimum payment on something with a credit card, you pay a lot more than the actual thing is worth because you're borrowing somebody else's money. So this is the interest, which this is actually a very low interest rate. A lot of them are 20, 25%. So if you look at it and you go back and you see, well, we paid this much money. What if we just saved up instead? How much would it cost if we saved up and just paid $50 times 12? What would that be? It's only $600. So when you use somebody else's money, it costs $429.21. You're paying the bank about $430 just to borrow their money and pay it off over a year rather than saving up the $600 and buying it at one time. So this is why you don't want to do this. You want to save up everything, buy the whole thing at once so you don't give interest payments to banks. And that way you have extra money to buy things you really need, right? So credit cards could be very good only if you pay them off at the end of the month, and you don't have to pay any interest. But as soon as you don't pay it off, or you take a year to pay something off, that $600 tablet, you're now paying almost twice as much. I mean, it's almost $1,100, which is almost $1,200, which is almost twice as much. You can buy almost 2 iPads if you just do it that way. Okay? All right, so that'll be it for today.